Hello student, this question has been asked in JEE 2025. It says it is basically the type is assertion reason type. The assertion says if Young's double slit experiment is performed in an optically denser medium than air, the consecutive fringes come closer. So first the Young's double-slit experiment, that is YDSE, is performed in air. Then suppose the fringes looks like this. This is a bright fringe, then a dark fringe which I represent by simply blank, and this is again a bright fringe, then again dark fringe, again bright fringe. Okay. The question says when the YDAC Young's double slit experiment is performed in a denser medium than air, denser medium, then the fringes will come closer. Okay, then the fringe will look like, according to the question, the fringe width will decrease. Correct. The fringe width will decrease. I try to decrease the fringe width. Okay, okay. So this will look like the width are decreased and they come closer, the consecutive fringes. Okay, now let's read the reason. It says the speed of light reduces in an optically denser medium than air, while its frequency does not change. When light enters, suppose this is air medium and this is some denser medium, maybe water. Okay, it is denser medium. When light travels from one medium to another medium, suppose here light travels from air to water medium. Okay, some bending will be taken place here, but I am not showing here. Okay, the reason says the frequency does not change, which is correct, and the speed of light reduces in an optically denser medium. We will check if the speed increase, decrease, or remains unchanged. We'll check. See, suppose this is a light wave, correct? Signal which is present here, when it comes to this point, this length is lambda of the wave and it takes the time capital T, that is time period, correct? So the speed, distance traveled by time, this is the relation. So V is equals to lambda, T is time period, we can write it as 1 by T means frequency f, correct? So the speed of a wave V is equals to lambda times frequency, and frequency does not change. It depends only on the source of the wave. As long as the source is not changing, the frequency of the wave will not change. Frequency is constant. So here we can write V proportional to lambda or lambda proportional to V. Lambda proportional to V. Correct. So again we need one more formula from the YDAC, that is beta. Beta is the fringe width. Beta is the fringe width. Beta is equals to d lambda by d. What is capital D, small d, and lambda? So this is a slit, this is a slit, this is screen. The distance between the source and screen is capital D, and the distance between the two sources is small d, and lambda is the light incident on the YDAC. Okay, so here we can write as beta proportional to lambda. The distance between the source and the screen is not changing. The distance between the two source is also not changing. So we can write beta proportional to lambda. And again we got here lambda proportional to V. So beta proportional to V. Correct. Again see the speed. V is equals to lambda times F. F is not changing. The speed in vacuum is C. and when it comes to some denser medium, its speed becomes slower. Correct. Speed of light in vacuum is maximum. So V decreases, and as V decreases, the fringe width decreases. So this is the reason. So the reason is correct, and the assertion is also correct. Correct. Beta is decreasing. That is, the fringe will come closer. So the assertion is correct, reason is correct, and reason is the correct correct explanation of the assertion. Thank you.